Welcome to this special Aman water video where we are going to map the invisible world of software, the tools that support the engineers of tomorrow. If you walk into a water engineering design office today, you will rarely see an engineer with a ruler, graph paper and a calculator. No, you will see screens, simulation windows, interactive maps, real-time charts. Software has become the natural extension of our technical reasoning. Why have they become indispensable? Because water engineering today is complex. We manage entire networks stretching over several kilometers. We must anticipate the behavior of water in all situations: rain, drought, fire. We work with regulatory, budgetary, and environmental constraints, and all of this must be modeled, compared, adjusted, optimized. Without software, you spend hours calculating head losses by hand. You redo every plan at the slightest change and risk missing errors that are invisible to the naked eye.
And above all, you sleep very little.
Exactly. A good software does not replace the engineer. It allows them to focus on real decisions. How to solve a problem. Which scenario is the most sustainable? Where to invest first? That is what we are going to explore together in this video. Computer-aided design to draw plans, trace networks, create longitudinal or cross profiles. Example: AutoCAD, QGIS, Civil 3D. Hydraulic simulation to model the behavior of water in pipes, reservoirs and basins. Example: EPANET, SWMM, InfoWorks, WaterGems. Geographic information systems to work with interactive maps, networks, elevation, flood zones, etc. Example: QGIS, ArcGIS. Specialized calculation tools to carry out precise designs, head loss balances or custom tools. Example: Excel, Canalys, EPANET Toolkit, VBA Forms. Project management and BIM to plan, track and coordinate projects and sometimes build a 3D digital model. Example: MS Project, Revit, Notion, Power BI.
In summary, I draw, I simulate, I map, I calculate, I manage.
Exactly. And in the rest of the video, we will review each family with concrete software, their uses and especially their limits. We continue our tour of the tools with CAD and DA software, that is, computer-aided design and computer-aided drawing. Their role: to allow you to precisely draw structures, pipelines, plants and networks. This is where plans, longitudinal profiles, trenches and slopes are born. And when you work on a real project, if your plan is badly done, your construction site starts badly. It is therefore crucial. First, software: AutoCAD. It is the great classic. AutoCAD is used in almost all design offices. It is not specific to water, but it is the foundation of technical drawing. You can draw pipes, manholes, topographic plans or even import map backgrounds. But beware, AutoCAD alone knows nothing about water. It does not know what a gravity pipeline or a minimum slope is. Second, software: QGIS, a module for AutoCAD. This is where QGIS, a module developed by GeoMedia, comes in. It transforms AutoCAD into a specialized tool for VRD, roads and various networks, engineers. With QGIS, you can automatically trace water supply or wastewater networks, generate longitudinal profiles with elevation, manholes, slopes, etc. Calculate excavation volumes, automatically list the elements to install, pipelines, manholes. And above all, QGIS understands the technical constraints of water engineering.
It is a bit as if AutoCAD finally spoke our language.
Another interesting option: Civil 3D. More oriented towards 3D modeling, it is widely used in BIM environments. But be careful, it requires more training time and is often heavier on machine resources. Now let us move to a family of software absolutely central in the profession: hydraulic simulation tools. Their objective is simple: model the real behavior of water in networks to anticipate what will happen on the ground. You want to know if a pipe can withstand peak hour flow? If the pressure will be sufficient at the top of a neighborhood? If a wastewater collector will overflow during a storm? You do not have to wait for it to happen. You simulate. First tool: EPANET. We start with EPANET, a free software developed by the US EPA and used worldwide. It is used to model pressurized drinking water networks, reservoirs, valves, pumps, pipes, nodes. You enter your network, elevations and consumption, and EPANET calculates the pressures at each point, flow velocities, head losses and water residence time. Advanced version, Water Gems. If you want to go further, Water Gems is a commercial version developed by Bentley. It offers a more ergonomic interface, optimization functions, and above all calibrated dynamic models with scenario management. It is often used by large utilities or major design offices. But beware, EPANET cannot handle wastewater. For that, we change tools. SWMM. SWMM, Stormwater Management Model, is also an open-source tool specialized for free surface flow, stormwater, combined networks, retention basins, overflow structures. It takes infiltration, runoff, temporary storage and even smart valve control into account. And for complex projects like large cities or entire watersheds, the reference software is InfoWorks, developed by Innovyze. Very powerful but also very expensive. It allows you to couple drinking water, wastewater and stormwater networks, simulate surface flows per second, test smart management strategies and even integrate real-time sensor data.
Free or paid, simple or ultra-complete, the most important thing is to understand what you want to simulate, not to buy the biggest software on the market.
When we talk about water, we often talk about space. Where does the pipe pass? What is the slope of the terrain? In which zone could flooding occur? All of this is visualized thanks to GIS, Geographic Information Systems. A GIS is like a professional-grade GPS capable of overlaying layers of information: drinking water network, topography, land use, flood zones, intervention locations, or even consumption data by neighborhood. And the two giants in this field are QGIS, free, open source, very complete, used by many utilities and design offices. With QGIS you can import plans, maps, GPS data, create thematic maps by pressure, flow, pollution level, manage databases linked to geolocated points, run spatial analyses. It has a slight learning curve but a huge community and very useful extensions for water. ArcGIS, developed by Esri. The other major reference, very powerful especially in its professional version ArcGIS Pro, but also paid. It is often required in public contracts or international projects. Advantages: smooth integration with other industry software, specialized modules, high-level technical support.
It is a bit like Google Maps but for engineers. With a good GIS, you do not just save time. You gain precision, traceability and safety.
After plans, maps, simulations, let us move to raw calculation. Because before drawing a network or buying a pump, you must size the diameter of a pipe, the volume of a basin, the peak flow, the allowable head loss, the residence time. For this, some software are not used to draw but to calculate. Excel and its engineering extensions is the simplest and most powerful. Yes, Excel that we all know is used everywhere in water engineering. But not just to make tables. With formulas, dynamic charts, and especially VBA, you can create head loss simulators, settling or biological treatment calculators, smart sheets with drop-down menus and alerts.
You can even create your own mini software if you know how to use it.
Exactly, and some design offices have developed internal custom tools capable of competing with paid software using only Excel. For developers or more technical engineers, there are toolkits like the EPANET Toolkit. Objective: program your own simulation modules, automate calculations, test variants via script. So far, we have talked about tools that help design a project. But once everything is modeled, it must be built, monitored and delivered on time. And here come project management tools. They do not handle water, but they handle tasks, deadlines, costs and teams. For planning tasks, setting milestones, tracking progress, MS Project remains a historic reference. You manage the project phases: studies, construction, commissioning, human resources, delays, critical paths. In more agile teams, lighter visual tools are used such as Trello, card and column management, Kanban, Notion, a mix of database, project page and planning, Asana, more task and team-oriented. They are used during the study phase to distribute responsibilities, log checks to perform, track internal validations. They are not water engineering tools, but they facilitate organization and communication. For projects requiring a 3D digital model, we enter the BIM universe, Building Information Modeling. The main software here, Revit, developed by Autodesk. With Revit you can build a 3D model of a treatment plant, integrate buried networks, equipment, structures, simulate interferences between systems and extract quantities or technical sheets. It is mainly used in large urban projects, complex public tenders, international calls for proposals, and for data visualization in operations or reporting. Power by Microsoft or Looker Studio, Google. You can create dashboards with field data, sensor data, efficiency, losses, performance indicators, KPIs or dynamic reports for elected officials or funders. This is where numbers become beautiful.
These tools do not model water, but they model time, effort and teams, and without them, a well-designed project can easily go wrong.
We have just discovered around 10 software tools, but you may be wondering the real question: where do I start? Which one is truly useful for me? Here are 4 simple questions to ask yourself before starting. What is your precise need? Are you making plans, simulations, sizing calculations? No need to learn everything at once. What is your context? Are you an intern, in a design office, in a technical department? Each environment has its preferred tools. What is your budget or the budget of your organization? Some software are free, EPANET, QGIS, others very expensive, InfoWorks, Revit. Is there a community or tutorials available? Software without documentation is a labyrinth without a map. And if you do not want to choose blindly, start with what we showed you today. And above all, tell us in the comments which software you want us to explore in detail in a future video. A tutorial on EPANET, a demonstration on QGIS or even a custom Excel calculation sheet. And now, grab a glass of water and stay hydrated. If you're into this topic, don't forget to subscribe, hit the bell, and come with us to explore the world of water.